Making buffer solution. There are 4 ways of making buffer solution. One of them is weak acid and conjugate base in ratio 1:1. The second way is weak acid and strong base ratio 2:1. Third, weak base and its conjugate acid 1:1. Fourth, weak base and strong acid ratio 2:1. It is not what you start with, but what you end up with that matters. For weak acid and the conjugate base, HF is the weak acid, its conjugate base is F-, and the salt is what we need to carry the F-, and then sodium fluoride, and the ratio will be 1:1. For number 2, weak acid, HF, and strong base. The strong base will be sodium hydroxide, and HF plus sodium hydroxide will give sodium fluoride and water. So we got the weak acid that we need, and the conjugate base, NaF, as the salt. Remember the ratio is 2:1, so we got 2 of HF and 1 of NaOH, 0, 0 in the beginning. And the change will be that the limiting reactant is 1, is sodium hydroxide, because it's 1, and this is twice as much. So we take away minus there because we're going to use it all, and it dissociates completely in water, so it will react with HF. And again, so we need the same because it's ratio 1:1. So we take away again minus 1 from there to now form ratio 1:1 plus 1, and a gain of water plus 1. And so we would form 2 minus 1 is 1, that's ratio 1 that we needed, and that would be used up completely, and we're going to form NaF, 0 plus 1, 1, that's the ratio 1 that we needed. So we start with that one of 2:1, and we end up with 1:1, which is what we need. Now this is our buffer solution using weak acid and a strong base. We can use weak base and strong acid ratio 2:1. The strong acid is HCl and the weak base is NaF. NaF plus HCl will give you sodium chloride plus HF. In this case, it's ratio 2:1. Here's the ratio 2:1. 2 NaF, 1 HCl, giving you initially 0, 0. So HCl is the limiting reactant, so we're going to use it all. And it will dissociate completely because it's a strong acid, so that would react with NaF, and so you're going to have the same ratio 1:1, so that's minus 1, minus 1. You're going to gain plus 1 and plus 1 because it's ratio 1:1, stoichiometric mole. At equilibrium, you would have 2 minus 1, that's 1, that's what we need. The NaF, the conjugate base, large quantity, 0 of HCl, and HF, large quantity of 1, ratio 1:1. So that's using a weak base and a strong acid. For the weak base, you could have NH3 and NH4 plus on ratio 1:1 here.